In part one of our Introduction to Linear Programming, we are going to look at the type of problem where we are given the objective function and the constraints and asked to find both the minimum and the maximum value of the objective function that satisfies all of these constraints. In a bigger picture, in general, you are usually asked to only find the minimum or the maximum, but for these first two we're going to find both. Now the key fact that drives all of this is this. Given any objective function, when we look at only values that satisfy all of the constraints, both the minimum and the maximum value of the objective function will occur at intersections of the constraints. All right, let me say that again. Both the minimum and the maximum value of the objective function will occur at intersections of the constraints. All right? So that's something you have to keep in mind. Now, the first step is to graph the constraints. All right? So, in this problem, we have our first two constraints here. X is greater than or equal to 0, y is greater than or equal to 0. You have those in every problem. The variables involved are all greater than or equal to 0. And then we have two additional constraints in this one. So let's start off by graphing them. Okay, well, the first one, x greater than or equal to 0, really gets us the y-axis here. And where everything is going to be greater than or equal to 0 will be on that side, right? And then y greater than or equal to 0 gets us the x-axis, and everything will be above it. So these first two make everything be in the first quadrant. Next, we have 2x plus y is less than or equal to 8. All right. So just with all inequalities, we'll start by graphing it as if it was an equation. So if x equals 0, that leaves us with y equals 8. And if y is 0, that leaves us with 2x equals 8, which gives us x equals 4. All right. So we get the point 0. Let's see, 2, 4, 6, 8. So 0, 8. And 4, 0. 2, 4, 0. There's our 2 points. And we'll connect the dots. And then since it's an inequality, one line or one side or the other of the line, right? So if I test 0, 0, 0 plus 0 is less than 8. So that puts us on this side of the inequality, right? All right, then the next one, 2x plus 3y less than or equal to 12. Well, if x is 0, that leaves us with 3y equals 12, so y is 4. If y is 0, that leaves us with 2x equal to 12, so x is 6. So this time I get 0, 4 is 1 point, and 2, 4, 6. 6, 0 is the other. And again, we will connect the dots. And again, use 0, 0 as your test point, and 0 plus 0 is less than or equal to 12. So now we're in here, right? So our area is this bit in here. And remember, we're looking for the max and the min, and they occur at the intersections of our constraints, right? There's one intersection, 2, 3. We have these 4 intersection points this time. All right. So our intersection points then are x equals 0, y equals 4. We'll take 0, 0, 4, 0. And then this last one here, we're actually going to have to calculate, unless you drew your graph like with machine precision somehow. So we'll take the two equations to make that up. So 2x plus y equals 8. And 2x plus 3y equals 12. There's actually several ways you could do this. What I'm going to do is I'll use elimination and just subtract the bottom equation from the top one. So 2x minus 2x gives me nothing. Y minus 3y gives me minus 2y. 8 minus 12 gives me minus 4. Divide both sides by minus 2. Y equals 2. I'm going to take the 2 and plug it back into either equation. I'm going to use the first one. Putting the 2 in for the y gives me 2x plus 2 equals 8. 2x equals 6. x equals 3, right? So I get x equals 3, y equals 2, and my last point is 3, 2. Then we just plug each of these points into z, which, as you'll remember, is 2x plus 3y. All right. Well, if I plug in 0 and 4, that's 0 plus 12 is 12. If I plug in 0, 0, that gets me 0. If I plug in 4, 0, that gets me 8 plus 0 is 8. And then 3, 2 gets me 6 plus 6 is 12. So our minimum z is 0, and it occurs at the point 0, 0. And our max z is 12, and this time it happens at 2 points, right? It occurs at 0, 4, and again at 3, 2. Okay, so we've gone through this. That's it for the first problem. We found the min at 0, the max at 12, and the points where they occur. Let's look at the next problem. In this case, we have a different objective function, different constraints, but the same general idea. We're being asked to find both the maximum and the minimum value. Okay, well, we start by graphing our constraints. And again, x greater than or equals 0 gets us the y-axis here. And greater than or equal to 0 is going to be on that side. Y greater than or equal to 0 gets us the x-axis, and that's going to be that side, right? All right, so 2x plus 3y equals 12, right? We're going to graph the equality version of this. So if x is 0, y is 4, and if y is 0, that leaves me with 2x equals 12, x is 6. So we'll graph that. So we want 0, 4. So 2, 4, there is 0, 4. And 6, 0, 2, 4, 6. There's our point. So we have our 2 points. We connect the dots. Our test is 0, 0, and 0 plus 0 is less than 12, so we're on this side of that line. Next, we have x plus y equals 3 is the equation version. So if x is 0, y is 3. If y is 0, that leaves me with x equals 3. So 3 is going to be there and there. And we connect the dots. Wasn't a very good draw. Let's try that again. Connect the dots. This time, 0 plus 0 is not greater than 3, right? So we want the other side of the line. So this time we're going to have the area in between up here that we're looking at, okay? So our 4 intersection points are going to be on the boundaries of that. Okay? So our points are 0, 3, 0, 4, and 3, 0, 6, 0. And if you remember, our z is 4x plus y. Now, so we just plug these in. If I plug in 0 for x and 3 for y, I get 3. 0 and 4, I get 4. 3 and then 0, I get 12. 6 and then 0, I get 24. All right. So this time, the minimum z is 3. And it happens at the point 0, 3. And the maximum z is 24, and it happens at the point 6, 0. That is it for this one.